Welcome to Gradient Boosting with XGBoost in Python. In this lesson, you will learn the basics of how to use gradient boosting with the powerful XGBoost library. We will work step by step, using a real-world dataset to predict who survived the Titanic. You do not need to know machine learning yet. Let us get started and see how simple it can be. Running the cell now. We are bringing in the packages that will help us work with data, train models, and show results. We use warnings to hide extra messages. This keeps the notebook neat and free from extra warnings. Pandas lets us work with tables of data easily. NumPy is for handling numbers and arrays fast. XGBoost is the machine learning library we are exploring. We use train test split to split our data into parts for training and testing. Accuracy score helps us find out how well our model is making predictions. Running the cell now. What is gradient boosting? Gradient boosting is a clever way to make strong predictions by combining many simple models. Each simple model learns from the mistakes of the last one. This helps the final predictions get better and better. Running the cell now. Now, we are loading the Titanic data directly from the web. We store the link to the dataset. We use pandas to read the dataset and put it into a data frame, which is like a table. Let us see how many rows and columns we have. There are passengers and their details. Here is a quick look at the first few rows so you can see what information each person has, such as if they survived, age, and more. Running the cell now. What stands out to you in the table? Take a moment to look at the columns. This shows us the number of people who survived and who did not survive on the Titanic. A count like this helps us see if our data is balanced or if there are way more of one group. Running the cell now. About the features. Our table includes details like sex, male or female. Age. Passenger class, first, second, or third. Number of siblings or spouses aboard. Fare paid. These are the features we will use to help predict survival. Running the cell now. This lists the columns, or fields, in our dataset. It is important to know what information we can use for our predictions. Running the cell now. Sometimes, data is missing for some people. Here, we fill in missing ages so our model does not get confused. We use the average age as a simple guess for missing values. This is a common way to keep things simple for learning. Running the cell now. Computers work with numbers more easily than with words. We turn a male into 0 and female into 1 so the machine can learn from this feature. Running the cell now. Now we choose only the columns we want for our model to learn from. These are the columns, or features, we listed earlier. X holds the feature data for each passenger. The variable Y is what we are trying to predict. Here, Y is if someone survived or not. Running the cell now. Splitting data means putting some aside to test our model on new, unseen people. We use 80% to show the model answers and 20% to check how well it learned. Running the cell now. Why do you think it is important to test on data the model has not seen? Training an XGBoost model. Now let us build a model that predicts survival. We will use XGBoost. XGBoost stands for Extreme Gradient Boosting, and it is very popular for competition and real-world problems. Running the cell now. We are making an XGBoost classifier object to solve our problem. The model learns from our training data. Now, it tries to figure out patterns in who survived based on the features we picked. Running the cell now. After training, we ask our model to make guesses, or predictions, on the new passengers in the test set. This gives us a list of predicted results who the model thinks survived. Running the cell now. It is time to see how good our model's predictions are. We calculate accuracy, which means what % of predictions match the actual outcome. Printing the result lets us see how close we are to getting things right. Running the cell now. Try changing the features you use and see if the accuracy changes. XGBoost model parameters. Every XGBoost model has settings we can adjust, called hyperparameters. The most important ones are n_estimators, how many trees; max_depth, how deep each tree goes; learning_rate, how much each tree corrects the last. Changing these can make your model better or worse. Running the cell now. Here, we make a new model with just 50 trees, a depth of 3 for each tree, and a learning rate of 0.1. After the model learns, we do predictions with the new settings. Finally, we check if our accuracy improved or changed after tuning the parameters. Running the cell now. We can let you change how many trees and how deep they should go. Type in numbers when asked. The model will update and show you the new accuracy. This is how you experiment and learn what makes models stronger or weaker. Running the cell now. Try out at least 2 sets of numbers to feel the differences yourself. Feature importance. One great strength of XGBoost is showing which features matter most. Let us look at which feature helped most in predicting survival on the Titanic. Running the cell now. Now we import a tool called Matplotlib to make simple charts. This code makes a bar chart, showing how much each feature mattered to the model. The higher the bar, the greater the effect that feature had in making predictions. Seeing charts like this helps you understand what the model is looking at. We add a title to the chart for clarity. Our chart pops up and you can see right away what matters. Running the cell now. Mini project, predict a single passenger. Let us use our XGBoost model to predict for just one new Titanic passenger. Input some details to see if they might have survived. Running the cell now. Let us try making a prediction for one passenger. Here, you will type their travel class, which is first, second, or third. Next, type if they are male or female, by using 0 or 1. Type their age in years. Enter how many siblings or spouses they have aboard. Now enter how much they paid for their ticket. We put all their details into one row for the model to read. The model predicts survival, giving 1 for survived or 0 for did not survive. See instantly if this imaginary person might have survived. Running the cell now. What do you notice when you try different values? Practice with a few examples. If you are finding this useful, consider liking or sharing the video. Models sometimes fail if data is missing. This quick check shows if any features have missing values in our test set. Being aware of missing data is a great habit for real projects. Running the cell now. Here is a tip: pipelines help organize many steps of modeling into one piece. We import pipeline from scikit-learn. Building a single pipeline lets you fit and predict just like before. This keeps your code tidy. The model learns just as before. You can get predictions from the pipeline just like before. Finally, we check the pipeline's accuracy, just to see that it works the same way. Running the cell now. Pipelines are helpful when your projects get bigger. For a challenge, let us use just a few features: class, sex, and age. This helps you learn whether using more information always improves your model. We again split the data into training and test sets. Make a new XGBoost model as before. The model learns from your smaller set of features. Now you see how well it does with the new setup. Looking at the accuracy tells you if fewer features are hurting or helping. Running the cell now. Recap: what have we learned? How to load and explore a real dataset. What gradient boosting is, in simple terms. How to train and improve an XGBoost model. How to check which features are important. Ways to test and predict survival for new passengers. You now have the basics to use XGBoost in your own projects. Running the cell now. Next steps. Try the challenge cells again, or use this template for your own dataset. Experimenting is the best way to learn. Subscribe to the channel for more hands-on Python notebooks and challenges. Running the cell now.